Okay, guys, in 3D, when we talk about two lines, uh, what can be the relationship between these two lines? We have to discuss that, okay? In 2D, you see that in 2D, when we have two lines, the two lines can either be parallel. For example, there is a line L1 and this is the line L2. If they are parallel, that means they are not never going to be intersecting. And the second case is if they are not parallel, then they will definitely be intersecting at a point. They will have a point of intersection. So in 2D, we can have two lines parallel and non-parallel, parallel or non-parallel. Okay. But in 3D, we can have there can be three cases. Okay, first of all, two lines they can be parallel. Okay, no problem. They can be parallel. Okay, so the lines L1 and L2 are parallel. Now, suppose in 3D, one line is going like this, the other line is just passing below it like this. Okay, and they are not intersecting like it is going like this. Okay, so let's say there is a gap of 10 feet between these two lines. Okay, so like for example, if you see that there is a line like this on your floor and there is a line like this on your ceiling. Okay, or there is a line like this on one of the walls and the other wall in front of it that can have a line like this. Okay, so they are never going to meet together because they are far apart. Okay, but they are non-parallel as well. So uh, the first case is when we have two lines, the lines can simply be parallel to each other. Okay, now the second case is when you have non-parallel lines. Okay, when you have non-parallel lines. So these two non-parallel lines, they can either be intersecting, okay, non-parallel and intersecting, or they can be non-parallel and non-intersecting. Now you take an example here. For example, you have a line which is R is equal to 2, 3, 5, and then plus lambda into 1, 2, 7. Okay. And then there is another line whose equation is, let me take it as R1. Okay. Now R2 is 3 minus 1, 4. And then we have plus mu times uh, 10, 20, and 70. Okay. You can see that like the direction ratios here are 1 ratio 2 ratio 7. And here, if you simplify them, they are also 1 ratio 2 ratio 2 ratio 7. So by looking at the direction vectors, you can at a glance tell that if the two lines, they are parallel or not. Now, these two lines, they are parallel. Okay. So Claire, how to determine if two lines are parallel? You simply have to look at the direction ratios. Okay. Uh, now, if suppose if one of the line was like this was like this, and this was, there was minus 10 over here. Now, are these two lines parallel? They are non-parallel because there is a difference in their direction ratios. Okay, so if you don't have the same direction ratios, that means the lines, they are non-parallel. Now, how to decide if they, like, we know that they are non-parallel, so now we have to determine that if these two lines are intersecting or non-intersecting. Okay, so there is a long process for that. I'll just tell you in a minute. Okay, we have a question here from this exercise 9E. Now it says, find whether the following pairs of lines are parallel. Now just keep it up to parallel. I'll tell you about the intersecting or skew. Okay, so if you look at this here, in this A part, you have the coefficients of the lambda here, like 3, 5, 4. So the direction ratios are 3, 5, 4. And here you have the direction, the coefficients of mu, that is 1 ratio 1 ratio 2. So you see that these are two different direction ratios. So the lines uh, in this part A, they are non-parallel. Okay. If you look at the part B, in part B, we have the ratios for this line. You have the ratio uh, this is 3 minus 4 and then 9. And over here, if you simplify this, if you take a minus 2 common from here, so that is also going to be 3 ratio minus 4 ratio 9. So in part B, you have two parallel lines in part B, okay? And if you look at this part C, here you have the direction ratios here are 1 ratio 3 ratio 9, and here you have 8 ratio 1 ratio 14. So they're clearly not the same. So in part C, you don't have parallel lines, okay? And similarly, I can simplify this. This can be written as 3 ratio 2 ratio minus 1, and this you can take a minus common from here. This is 1 ratio 8 ratio 1. So again, these are non-parallel lines. So there was just one pair of parallel lines that was in part B. Okay, now I have to tell you how to determine if we know that if the two lines are non-parallel, how to determine that if they are intersecting or non-intersecting. Okay, so for that purpose, you will have to be very alert and see how I will be doing this. This is a very long process. Okay, normally it's a question of 5 marks. Okay, now. Um, so we know that this in this part A, the two lines, they are non-parallel. Okay, when the two lines are non-parallel and non-intersecting, we say that these are skew lines. You can see that he has used the term skew over here. Okay, so um, can I show you the word skew being used? Yeah, here it is. This word skew. So this means, you can note it down, that this skew means non-parallel, non-intersecting. Okay. So now let's take this first part over here and try to see that if they are intersecting or non-intersecting. So this will be a long process, so you have to be alert. Okay. Now, luckily, we have been given their their parametric equations. So that will be your first step. You will always write the parametric equations. Okay. So from uh, the first line, you have 3x as 3 lambda plus 4. And then you have y is equal to 5 lambda plus 1. Then you have z is equal to 4 lambda minus 3. Okay. So eh, I can call this relation number 1, okay? And then from the second line, you have x is equal to mu plus 1, you have y is equal to mu plus 4, and you have z is equal to 2 mu plus 5, okay? So this is your second relationship over here. Now from these two relations, you see this is x, this is x. So you will equate x with the x and y with the y and z with the z, okay? So from 1 and 2, we shall say that, okay, from this 1 and 2, we can say that this 3 lambda plus 4 is equal to mu plus 1. We can simplify a bit. This is mu is equal to 3 lambda plus 3. That is equation number 1. Then we equate y with the y, okay? We are equating y with the y. So we have 5 lambda plus 1, that is equal to mu plus 4, okay? So I'm intentionally writing them like as mu equal to. You can write them in any way you want, okay? Now, for the z equal to z, we have 4 lambda minus 3, that is equal to 2 mu plus 5. You can write it as 4 lambda, that is equal to 2 mu plus 8. Now, that is the third equation. Now, listen to me very carefully, guys. We have three equations in mu and lambda. You have to choose any two of them. You feel you can solve them more easily. So you see that since I had written them both as, like, mu as the subject here, so I can solve these two equations here. Okay, so I will be solving the equation number 1 and 2 simultaneously, so that I can find the values of mu and lambda. Now I'm going to equate them because they are both equal to mu. So I have now this 3 lambda plus 3, that is equal to 5 lambda and then minus 3. Now, please keep an eye on my working. You know that I am very keen of making silly mistakes, okay? So 2 lambda, that is equal to minus 6, and your lambda is equal to minus 3. So this is the value of lambda we have, okay? And now you put this into equation number 1 or 2 to get the corresponding value of mu. So that is going to be minus 9 plus 3. Okay. So your mu is going to be minus 6. Okay. Now we reach the climax of this working. So by using,
सर इंतजार
yes, yes, yes.
2 lambda is equal to 6 नहीं होगा plus 6.
Lambda is equal to, yes, you see, I have made a mistake here. Thank you very much, Beta, for this. 2 lambda. God bless you. So, and then we have this mu as 3 into 3 is 9 plus um, 12. So this is going to be 12. So this mu is 12 with us. Okay. So we have got the, thank you, Beta, once again. So by solving two of these three equations, we have got the values of mu and lambda. Now, you have to test the third equation. Okay, you have to substitute these values into the third equation that you didn't use at all. Okay, if this third equation is satisfied, that would mean the two lines are intersecting. And if you don't get an identity, don't get this satisfied, so that would mean the lines are skewed. They are non-parallel and non-intersecting. Let's do that. So we are going to substitute the values of mu and lambda into the third equation. So from the third equation, we have 4 lambda. That means that is going to be 12. If that is equal to 2 lambda plus 8, that is 24 plus 8. Oh, so they are not equal. You see, they are not equal. So this means the two lines are, these are two skew lines with us. They are non-parallel and non-intersecting. Okay, got it, bacho? You must have any question here. Okay, now let's try this part C. Now we have the first equation is R is equal to, the first equation is R is equal to, now I'll be writing it as, you see, I've told you that I prefer working in matrix form. So I'll be writing it as 7 to 6 and then plus lambda into, this is 1, 3, 9. That is the first equation. And then I have the second equation, which is R is equal to 4, 1, 1. And then we have mu into 8, 1, 14. Yeah, these are the two equations with us, okay? Now this time you will have to write their parametric equations, okay? So from here, I have x equal to 7 plus lambda, y equal to 2 plus 3 lambda, and z equal to 6 plus 9 lambda. So this is the first,
Sir,
yes, 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 yes.
sir,
Yeah.
wouldn't the second equation be 141?
Oh, this is going to be 041. Oh, this is zero four
Yeah,
one.
sorry, 041.
Yeah, yeah, yeah.
Yeah.
Thank you, Beta. Thank you. Thank you very much. This is zero. How did I ignore this? This is 041 because there is no I over here. Thank you, Beta. Okay, so this is your, these are your parametric equations from the first equation. And then we have, you see, it was 4j plus k. So there was no I over here. So it had to be 041. 041. Okay, and then you have 8i j plus 14k, so we have 8 1 14. Okay, now from the second equation we have x equal to 8 mu, we have y is equal to 4 plus mu, and we have z is equal to 1 plus 14 mu. So that is the second set of parametric equations. Okay, now from these two sets of parametric equations. Now we shall obtain three equations in lambda and mu. Okay, so we should say that from 1 and 2 we have 7 plus lambda, that is equal to 8 mu. I can write it as lambda equal to 8 because you see, I have in my mind that I have to solve them later simultaneously. Okay, so I have lambda ready over here. Now from the second, which are y's over here, so we have 2 plus 3 lambda, that is equal to 4 plus mu. I can write it as just 3 because my lambda is ready, so I don't want any other simplification. I just move this 2 to the right hand side. This is 2 plus mu. So this is your second equation. And the third equation is 6 plus 9 lambda, that is equal to 1 plus 14 mu. Okay, so we have 9 lambda, that is equal to 5 plus 14 mu. That is the third equation we have. Okay, this is the third equation we have. Now we have to decide which two equations we would like to solve simultaneously. So you can clearly see that the first two equations, they are quite easy to handle. So I'll be solving the first two equations from 1 and 2. So I'll be putting this lambda from 1 into the 2, okay? So this would be 3 into 8 mu minus 7. That is equal to 2 plus mu. So if you are working side by side like with me, then you can check my mistakes as well, okay? And you can learn this well
सर
as well. Yes, yes.
आपका इक्वेशन 3 में -5 + 14 म्यू नहीं होगा
Let me check. This is 6 plus, yes, you are right. You see, because you're doing it, that is why you're keeping a check on it. Okay, 9 lambda, that is -5. Absolutely right, beta. Okay, so this is 24 mu minus 21, that is equal to 2 plus mu. Okay, so then this is going to be 22, 23, I think. 23 mu, that is equal to 23. Yes, you see these values of lambda and mu would justify that there has been no mistake. Okay, so this mu is 1. Now let's substitute this in the first equation. So this lambda would be 8 minus 7, so that is going to be 1 as well. Okay, so this is the set of the values for mu and lambda we have got. Okay, now, when you're solving this 1 and 2, suppose you got the value of mu, do not try to put this into the third equation because you have already mentioned that you're solving the first two equations, okay? Now, the third equation would be used to test if we have these intersecting or non-intersecting lines. If the third equation would be satisfied, so that would mean that yes, the two equations are intersecting. So now, from this third equation. Now 9 lambda, that would be 9 if that is equal to minus 5 plus 9. Yes, sorry, 14. Minus 9 plus 14. So yes, we have 9 equal to 9. So this implies that the two lines are intersecting. Okay. Hence, the two lines are intersecting. Okay, now from here I have the opportunity. Let me use this opportunity to tell you that how to find, suppose you had the question that if they are intersecting, then find the position vector, of the point of intersection. Okay, so this is just an added value over here for you. Okay, like from all this working, we're just going to use all this working to determine that what is that point of intersection, because you see that we have declared here, yeah, that yes, the two lines are intersecting. Then how to find the position vector of that point of intersection? So there are no worries, we have done all that working. You just put this mu into this mu valley equations over here. Okay, or you can put this lambda into this lambda wali parametric equations, okay? And you will like, you would love to see that both will give you the same point. So for example, if you put your lambda here, which is 1, so you will have 8, 5, and 15. That is the position vector of point of intersection. And look at this. If you put 1, mu1 here, you will have the same, like 8 ones are 8, 4 plus 1 is 5, and 1 plus 14 is 15. So that is how you can find the point of intersection of two lines as well. And at this point, I declare that our chapter on vectors is finished, and so is our syllabus. Our syllabus is also finished here, okay?